Hello, today I'm in the Aerospace Structures and Materials Lab, and I'm going to be creating some testing methods on the Instron uniaxial testing rig to do some cyclic tests on some of my specimens to see what my sensitivity is for vibration testing, which we'll be doing later on in a shaker table. So if you take a look at the screen here, I'm going to be using the Blue Hill software to enter this testing method, and we'll kind of go through it a little bit at a time. I've done this all already, but I'll give you a look at how it works. So the first thing we want to do is sample description and inputs. I don't have that in this method. These are the general averages for my specimen lengths and widths. These are the measurements available that we can record, which is time, displacement, and force are the ones that I'm using specifically as outputs, while compressive strain is being used as a control, and that's based on compressive displacement. The test control is the most important part of this testing method. To start it, you of course press the start button, and the strain source is displacement, as I mentioned before. We have no pretest here. I am going to be doing a small preload at the beginning of the test just to make sure we have good contact with the testing rig. And now we move on to the meat of the method. Now you can see that there's multiple sections here, and each of the first three sections is a cyclic mode. And this cyclic section is controlled by the compressive strain that's applied to the specimen, which is based on the inputs of length that I will put for each specimen before I begin testing. Now you can see that the strain rate is set to 0.9 strain per minute, and we begin by going to a maximum strain of 0.3%, and then down to a minimum strain of 0, and we do that 5 times. Similarly, for the next section, we have a larger strain rate, 1.8 strain per minute, and a maximum value of 0.6. Once again, go back down to 0, repeat 5 times. Similarly, for our final section, we have an even larger rate of 3.6, maximum value of 1.2, and then we repeat that 5 times. At the end, I have the strain going up to a value of 1.6, and what that does is, when I press my end of test button here, when it reaches 1.5, the test automatically stops. Now, I've run this method and I've seen that it works, and so the next step of this process for me to actually put some specimens on there, hook them up to our LCR meter so that we can get some electrical signals and run the test.